Hello everyone, and welcome to today's session taking a look at the all-electric construction machine. The first electric construction machine was presented at bauma in 2016. Since then, a lot of focus has been placed on improvement and proliferation. Stefan Schneider, the managing director at SUNCAR, will speak today about the challenges faced while working on the next level of construction electrification by giving an overview complete with some interesting examples. Please remember that if you have any questions during the session, to add them to the Q&A to the right of your screen. I hope you enjoyed this session, and with that, I will turn it over to Stefan.
Thank you very much for the warm welcome and the introduction into our session of the all-electric construction machine. I myself are managing director of SUNCAR and a former mechanical engineer, which have studied at ETH Zurich to learn how to electrify machines and vehicles. I would like to take you on the journey, what I have experienced myself throughout the vision of SUNCAR, which was a project based on the ETH Zurich with a professor which want to go and speed up the process to went into a more renewable future. We think that the renewable energy sources as solar, as wind, which are very important for the environment, for the future, need to be somehow used also into our mobile machineries and vehicles. In the end, what we have experienced and seen, thankfully to the automotive industry, that lithium-ion batteries has started to be a very important factor of enabling electromobility. And throughout the vision of SUNCAR is also, we have started in electrifying cars throughout the energy of solar and electricity. The idea was to electrify vehicles, electrify machineries, and bring these electricity into these mobile applications. We're trying to reduce emissions and also not only pollutions, we have also pollutions as noise, as vibration. There is much cleaner and better environment for also a job site, for the personal experience with an electric machinery. Therefore, we are trying to lead also the industry with full performance and zero emission, as also that was an enabler of the electromobility, and with Tesla as an example, with their first roadster, they have enabled acceleration, they have enabled to have fun with electric machine and vehicle. Therefore, we are trying to also go this path of making full performance available. I myself having also experience about driving electric cars, converting electric cars and making it available to different peoples which have never used an electric car. We started 2010 with building an electric Lotus Evora. It's the same base than the Lotus Elise, which Tesla has used and Elon Musk has used to build their Tesla Roadster. In these days, we also drag raced between these two cars, and our learning was we are losing the drag race and we're needing to focus on different, more niche segments. We're focusing now on construction machinery. And I want to give you some insights how we started to realize projects into the construction machinery field. We think the time is right, and now it's the time here to put the ideas into practice. We think it's a crucial point to mention that we are in an industry which is very conservative of making new changes. Construction machineries are here to work, to earn money, and to rely as long as possible. That's not a machine which you use for fun, for leisure. It's definitely to just earn money with it. And I think that's a crucial point where electric or e-mobility and electric driveline of such a vehicle need to make sense on the economics, that we have also less fuel costs, less maintenance on such machines. But we think throughout this conservative approach of different manufacturers, it's the time for a young team. As SUNCAR, we are now 50 engineers. We're based in Zurich, Switzerland, which trying to lead this engineering of electrification into these different machines. We're trying and hopefully partnering up with more and more manufacturers of different machines to help them to make the shift of the combustion engines to the future, the renewable drivetrains. We have started with different approaches, hybrid system, battery system. There are also even the experience to take the chance of using fuel cells. In the end, what we've seen the last couple of years, battery electric is the way to go, also for very robust and also quite power intense consumers, as these machines, as you have seen on the pictures here, a crawler crane which can lift over 200 tons. It has an engine installed with a continuous rating of over 200 kilowatts. But we see that the components are here. We are ready to make these ideas happen, and I think we as SUNCAR are willing and having the trust in ourselves and our engineering expertise, and taking the chance of making such machines available to the market. We know that the lithium-ion battery has enabled quite a lot, that it's more compact, that the operation time of such applications suits the needs of the customer. But even then, you need to be creative. The battery capacity should be as less as possible because it's the most expensive part of a machine. Therefore, we're trying to find solutions which are intelligent, using only as much battery as needed into any application to run a full day, a full operation cycle without any problems of not being ready to work. There is different approaches how that can be done, also with part-time grid connections, as you see also in the right picture. It's in the undercarriage, you're having a connector, a cable. A crawler crane is just moving before being stationary at work. Then again, there can be a grid connection, a peak shaving available to these machines to not supply all energy from the batteries, that you have also some capabilities of recharging it during operation. That's a different approach than you need to do it on mobile applications, wheel-based applications, which drives a long distance. These machines are in a limited area, in a limited construction site, available to be mobile, but also work semi-stationary. And then you have always the chance to equip and recharge it also during operation. But besides the batteries, you have also the engines. And I see electric engines, that's definitely not a problem. We have started years ago in other industries and segments of using electric motors throughout a very big range of power consumption. Therefore, there will be never limitations of having the right electric engine available to meet the power needs. Even though on the biggest applications, as mining, they have started to already use ahead of time hybrid system, because there wasn't the chance to bring the energy from the drive line to the wheel. It's easier to do that with electricity, therefore they use diesel engines with generators and electric motors at the wheel. We see that this concept has already introduced in some special applications years ago, and now being broader and broader broadcasted into various applications in the construction machinery field. How we are doing that as SUNCAR, as an electrification partner of this manufacturer, we are always starting in 3 phases. First is the feasibility study. There is more paperwork than ever again in the projects, where we're trying to narrow down all technical challenges. For example, how big the battery need to be for the operation time needed, what charging infrastructure and charging systems need to be installed, and what can be done also for additional efficiency improvement that these goals can be achieved. Then we have also important topics about economics. The machine which runs then with 0 emission or less emission is definitely more economics is better in terms of the fuel and energy consumption. It's very dependent on the price on energy and the source, how you will create your electricity. That's also having a big influence about the environmental impact of such an applications. But nevertheless, we can say that it's a very big differentiations between a car, which you can discuss after how many kilometers an electric car is more environmental friendly than combustion engine cars. You see various studies. My number, which I have in mind, is around 80 to 100,000 kilometers. Then you have achieved this 0.0 of having same CO2 emissions. Afterwards, with each kilometer, you're gaining and lead into their environmental differentiations between these 2 technologies. The good thing to look into machineries is that if you're converting the 100,000 or 200,000 kilometers of a car into hours, that's probably 2,000, 3,000 hours, which is the lifetime of a car. In machines, even the bigger machines, you will run the machine 15,000 hours. That's 5 times more. And you will have this breaking point of being more environmental friendly much more early. Therefore, it's a very good approach to start with machinery, with long lifetime, with long operation time, because you will earn more money and you will have a bigger impact to the environment. After doing the feasibility study, we are facing the next topic, that is the development of a prototype. That's our main topic and the topic which makes the most fun. In the end, we are realizing the first machines, the world's first in every category, to run fully battery electric. These machines are built depending on the size in our workshop, at customer workshops, and we deliver not only the engineering competence, also the full package of a battery electric driveline. With these first prototypes, the nearest customers, the most important customers, can gain the first experience of using these machines. these prototypes are not used to just put it on the fair and then on the side. They're built to put it into operations. We're trying to collect as many data as possible to also improve the engineering package and the solution as much as possible, to also ensure that the coming series production and the further development of the electrification is so mature that it's also ready for series production. Normally, as SUNCAR, we are handing over to the OEM itself, which is then again fully responsible of starting serial production in their facility and trying to suit the customer needs out in these markets, which are more and more investing into environmental friendly machineries. As SUNCAR, we have already a huge history of doing battery electric applications, machines, which we have presented now on the third Bauma 2022. We started 2016 with the world's first 14-ton battery electric excavator and a small 2.5 ton. In the meanwhile, the smaller machines has been already adapted throughout a big industry. We have seen small excavators coming directly from the OEM in different configurations, in different variants. But the next challenge is not only doing the small ones, because they're normally based on 48-volt system and more well-known technology and easier to handle, because it's in terms of high voltage safety below a limit of 60 volts. It is much more easy to maintain these products and to allow all people to still use the machine. The challenge is, if you're exceeding these limits of 2.5 ton machines, you're going more to more into the power needs of going over 60 volts DC, and then you're starting having a high voltage system architecture in these machines. As we are building a 6 ton, a 40 ton, and an 8.5 ton, different sizes of excavators, which are in a 400 volt or 700 volt DC architecture, which enables then more power, faster charging times, and ensure the reliability you need for such an application. And what's next? Our outlook is going to a much more optimized solution. We are trying to put up our level of engineering competence and optimization, which can be challenged throughout the efficiency of such a machine. I can showcase you 3 levels of making a machine electric. We start normally at level 1, that's electrohydraulic. In easy words, just replacing the diesel engine and installing an electric engine with batteries, chargers, and so on. Next step, next level will be optimizing the hydraulics, or even replacing some rotatory drives of the machine to be direct electric, because rotatory drives are easy. An electric motor make just rotation, and if you need linear activations, then you are at linear actuators, at hydraulics, to run these actuations and these movements. In the end, how to challenge that? There is also already possibilities which definitely need more reliability, more tests, and that would be linear actuators, to install it instead of hydraulic cylinders. That would be, in the end, level 3, more future, probably 5 to 10 years in the future. To bring you a little bit on the journey, how such a system looks like, if you're starting at this level 1, we're showcasing here our serial machine 8.5 ton excavator, which having a 700 volt system architecture, runs a 4-shift hour 2 times a day with a fast charging cycle of 1 hour. It's very important to have always the charging infrastructure as an environment to the machine, because the machines, the electric machines, are only as good as the charging infrastructure. Because afterwards, after 4 hours, 6 hours, 8 hours of usage, battery is empty. You need to recharge. If that experience is not good, you will be not happy after 1 day. Therefore, we also offering in various products already a solution to the charging. That's very crucial also for machineries. We have also installed on these machines 2 possibilities to recharge. There is one possibility with AC connection, onboard charger, that's up to 44 kilowatt, 63 amps, which enables the machine to be fully charged in 2.5 hours. It's even available to run the machine in dual mode, that's charging and working in the same phase. Then you should achieve a 24/7 operation without any problem. You will continuously recharge the battery and use the battery just as a peak shaver. If you're needing fast charging, you just plug in DC fast charging throughout the CCS. The machine then needs to be stationary and can be recharged in 45 minutes. What is needed to look a little bit into the machine? You're having a complete new rear of a machine where the diesel engine, tanks, and so on have been taken a lot of space. Now there is the most space consumed by the battery system. In the green, you see the battery in the middle, and then you're having a lot of different components around placed as a high voltage distribution unit, which is a safety box for the high voltage architecture and ensures a lot of safety measurements as insulation monitoring. We're having also, in addition, a DC-DC converter that has been the alternator of a diesel engine, and you're needing now these onboard chargers. You would have the chance to make it as an option on 22 or 44 kilowatt. That's a complete new system layout and system integration into such a machine. But on level 1, you will stick with the original hydraulics. That's a very important point, to have a very reliable machine, a machine which the user is knowing how it will work. The feeling of using an electric machine is the same. It's also driven by hydraulics, driven by the same inputs and outputs. That's just a very small difference than using a diesel machine. We're using in the most applications axial flux motors because they are more compact. They're having a little bit more diameter, but they're very compact, which are not consuming a lot of size in the machine, and having also the chance to having high torques available without any additional gearbox needed. How we ensure that the machine has been improved the last years? We have doing level 1 at least 5 to 6 years, just level 1 conversions of machines, but we have sampled from the first machines we have brought into the market, always all relevant user data, machine data. And we're seeing potential. We're seeing potential to optimize, to redimension, to making cheaper, to making better, and that's definitely driven by data. Data can be used to collect and analyze also what we have already installed 5 years ago. We are seeing how the battery lifetime has been changed over these couple of years. We have seen how the machines perform, how the user is using it, how it will be charged, and that helps us very to optimize these applications. And has brought us to the point where we stepped into a new project, which is ongoing and governmentally founded by the Swiss country, where we challenge to be more efficient. We're trying to here to have couple and multiples of improvements. We want to do the traction drive direct electric. With a wheel-based excavator, there is a lot of recuperation potential. Therefore, we're changing the undercarriage to be also driven direct electric on a high voltage system with a high voltage motor and inverter. In addition, we also electrify the slewing drive. For these people which are market aware, that have been already been known throughout hybrid applications of big excavators, which the rotations of the machines can be saved in capacities in batteries. That has already been pushed in some applications to recuperate energy with electric slew drive. We implement that now on a smaller machine and make also these improvements on smaller applications. And in addition, we are trying to optimize the hydraulics. The stick, bucket, and blade have been just an innovative pump solution, but the boom, that's the most intense driveline in terms of consumption and also recuperation potential, because if you're having some weights in the air and you're going down with your arm, at the moment with hydraulics, you're working against the hydraulic pressure to come upwards and also the weight, but you also going to work against the hydraulic pressure to push down. But what we want is the potential energy you have if you're in the air with your bucket and your weight, is just to fall down and brake and recuperate energy out of these situations. And that's a big potential, making the boom drive an electrohydraulic linear drive, where this recuperation is possible throughout a separate electric drive line, separate electric motor and pump. Overall, we are trying to improve the efficiency of the machines, and we're trying to, or defined our goal to making 35% more operation time available on the same applications with just these improvements. In the end, the solutions need also to be able to scale. Therefore, we are seeing if you're able to reduce the batteries in the same dimensions, it needs to be these additional costs invested into new technologies, into more complex architecture, need to be even out with the reduction of the battery capacity. And so far we have analyzed it. It's a good chance that that can be achieved quite soon in the future. I mentioned we're having different reduction possibilities of efficiencies. One is also having less idling losses because we can drive the pump on demand. We decouple for less throttling losses. And in addition, we're having also a lot of optimization potential in the hydraulics because we're having less peak shaving, where we can regenerate some potentials of the pressure and not having very different pressure potentials inside the machines, because we are dividing it into different drive lines. But that comes always, as an engineer, it comes always with challenges. And one is that we're having an electric swivel. We need to go with the upper structure system architecture, which runs on high voltage, also through the swivel drive to the undercarriage. That's a technical challenge, how this high power has been transitioning also during idling. Idling is most crucial because normally it's better if you're moving the upper carriage to the undercarriage to transfer the energy, because you can't use cable because the rotation of the upper carriage can be just in one direction. Therefore, you're needing that. Therefore, different technologies to transferring energy. But in driving, you are always idling with the same position of upper carriage and undercarriage, and that's a crucial point. A lot of energy need to go in the undercarriage, and that's definitely a challenge. Also, a challenge looking into road safety. We are driving with such machines also on roads, on legal roads. And we need to ensure safety with a braking system, with functional safety on the controllers and the driveline itself. And we need also some measures to ensure these safeties without having the standard and used and well-known technology and the hydraulics available in the undercarriage, in the end going direct electric. In addition, we have space constraints. We are having the challenge that electric motors are compacter than combustion engine, but are definitely also bigger than hydraulic propulsions. These hydraulic motors are so small and having so big energy density and power density, that's crazy. We are good at doing efficient, compact electric motors already, but in the end, it's not the same. And in addition, you have each power electronics and inverter per engine. That's also an additional part which needs to be installed, but the motor itself, that's a challenge to fit it into these different positions and make enough place available, and be also in terms of weight and additional challenges to come. That's definitely something which is not so easy to solve. But an electric motor has the huge potential of minimizing mechanical yaw losses, using recuperations to having energy taken back, which is otherwise just polluted through heat to the environment. And we've seen some first test results on the diesel machines that we have a potential of saving 30% of energy throughout the slew drive, and around 30% of energy driving on roads throughout the traction drive. We already estimated also some efficiency improvement of the overall machine, but very critical and important in all these discussions is how the machine will be used. There is no standard application where the machine is used always in the same way. That also rules for cars, whereas it's such a cycle is running through driving through cities, driving on highways. You can make percentages, but every customer is using their vehicle somehow else. And on machines, there is definitely multiple variety to use the machines. And it's hard to define how these consumptions and these efficiency improvements rules for an individual customer. But we're trying to assume and also seeing their market researches for a digging cycle, for a driving cycle, and we're seeing with 2 different prototypes we're building that we are having big improvements on the driving, and we have also big improvements through digging when installing this energy recuperation, this linear hydraulic system for the boom actuator. In some specific operation cycles as leveling, as grading, we have even more than 75% of lower consumption estimated. And what will be the future? That will be a direct electric without any hydraulics, with AR technologies. We're trying to see what could be the potential 10 to 20 years futuristic approach to build machines. And we definitely see it will be electric because it enables autonomy or easiness the way to implement different autonomy systems. And we are seeing also the benefit of your AR technologies, also teleoperation, to run different machines on different construction sites from one office. That's definitely also big challenges in the future. We are cooperating in these projects together with ETH Zurich, where we have all trained and learned a lot of our engineering expertise, and we're happy to cooperate again on more futuristic R&D projects together. Now we have started with a 2.5 ton electric machine to go into the direction of linear actuators and minimizing the use of hydraulics. One challenge is that these linear actuators are bigger than the hydraulic cylinders, and that's critical in terms of a good visibility. That's very crucial for the operation if you're still inside the machine. Probably that can be solved also with augmented reality or teleoperation. Then we have also the challenge that these drive lines are near, for example, also at the bucket cylinder, near dangerous working zones where rocks and others coming into the way and damaging probably these more critical components. You have also the full electricity, high voltage cables coming up to the front, which is definitely a challenge how to handle it. And in the end, you probably need to limit a little bit, depending on the arm layout, the dimensions and the freedoms of reaching every point in the room as the machine has done before, but it's also needing new layouts or designs of this arm design of an excavator that can enable then future freedomness of moving into any direction. In terms of the linear actuators and the motors, it's a challenge because of the vibration and the shocks. It's a challenge due to the needed braking system, the needed safety, because we want to have as less as mechanical losses as needed, but we also want to ensure safety in terms of having a problem with an electric engine that the bucket stays the same and not just falling down. There is additional braking system, but we need also some natural braking throughout the friction of a linear actuator to be there more safe. That always comes in the pros and cons into the recuperation potential, and we're trying to find there the best benefits. In terms of efficiency, we think we look back to what we have started with. That's the combustion engine. In summary, you're using 40% of the fueled diesel, of the fueled energy into the machine. We're just using around 14%. If we're enabling now electrifications, if we're enabling more and more efficiency improvements, we can step by step improve that percentage up to a point where we have already at level 1 170% more efficient driveline with using 40% of the energy which we inputted into the machine. And also, if you're using direct electric and no hydraulics anymore, we're again exceeding that limit that we're probably at 65% of inputted energy used in the actuator in the end. And in addition, augmented reality can be used to making access to very relevant excavator data, making also informations about safety topics very present to the user of the machine, because otherwise you're having a display. If you're using assistant system or attachments and so on a machine, you're having multiples of display. We have the imagination that these relevant parameters need to be visible always throughout the operation of the machine. That's always relying on additional sensors that will enable also future improvements of a machine's autonomy and assistance system. You're having additional sensors as accelerometers, gyros, pressure sensor, cameras, GNSS sensor to enable a more complex machine, but also a more machine which having more autonomy on itself. And these safety and warnings, and for example also seeing pipelines around throughout the digging process, can be very visible and transparent to end user. As SUNCAR, we are also trying to enable this path into automation of machines with lift and slew restriction systems, visualization and depth measuring of the bucket, and in future also automatic digging. In summary, you have a short demonstration in this video how these machines have been built, as also SUNCAR has started as such a project on ETH Zurich. There are 8 to 10 to 12 motivated students, from mechanical engineering or electric engineering and system engineering, which enables already a demonstration of such a new technology. And we are honored to be part still as SUNCAR, as a project leader of these projects together with the ETH, to see what the future can bring and use the technology available and present in the market to having electrification and automation happen. And then I want want to say thank you for your attention.
All right, thank you very much, Stefan. So we have about 10 minutes left here. We're going to try to make it through a few questions that came through in the chat. So the first one, so where do you see maybe the biggest limitation of the electrification of the off-road vehicles?
The limitations is in the end the application itself. The limiting factor is to having the energy stores available where the machines is needed. In the end, if you're using a machine somewhere far out without any availability of electricity, it is already a challenge. And the application, it's also very dependent on the consumption. If you're having an application with huge consumption, huge average consumption, that's not beneficial to run battery electric. But all these applications with having very much peaks and always idling and part of the operation cycle which are consuming less energy, that's the one to tackle the first.
All right, thank you. Next question here. So you mentioned in level 3 that using the mechanical linear actuators could be a potential future solution. How far do you think that is away for mass usage, and how do the costs compare to the hydraulic solutions we have today?
I think I mentioned somehow 5 to 10 years, and I would say that's for the first applications to implement. We will not start with probably making every cylinder in the machines already with linear actuator, just putting and placing these cylinders which having the most consumption, because then you're having the most benefit of recuperation. And there I already see some first applications with implementing some individual electric cylinders into the most crucial applications, and especially in excavator I think it will start at the small ones, 2 tons, 2.5 ton machines to challenge that topic. And probably you see already in 5 years the first products available into the market, which bring you either 30%, 40% more operation time, or 40% less big, smaller battery, which even out then normally on a break-even point the cost of the machine.
Yep. So, and I guess speaking of batteries, this next question, if you get into too much IP or confidential information, please try and keep it general. So the question is, which chemistry do you use in your batteries, and how have you kind of addressed the issues with the winter, the cold weather, some of the rough environments that these machines are in?
At the moment, we are mainly using NMC technology of lithium-ion batteries because it's in Europe better available than LFP, lithium iron phosphate batteries, which are more into Chinese market. I think in the end, up to a point 2024 right now, the technical differentiations between these batteries are not too big. There is applications which are better with one than the other technology, but in the end, we have seen the batteries are safe if you're having high energy demand and probably more also high power demands. You're a little bit better with NMC technology to small higher costs and probably using LFP, which is cheaper, but also having some limitations into the usage on cold weather conditions. But all battery systems we are using, there have been installed cooling and heating mechanisms to be actively managing the temperature from a battery system. Without any management, the lifetime will be reduced. That's probably only possible for smaller applications, which is not so relevant of having high lifetime availability.
Right. Thank you very much. The next question is, I guess, more of a statement. So give me a moment, and I'll try and formulate it into a question. And it deals with, again, along the same lines of batteries. Can you maybe address your thoughts on the benefits or lack of the photovoltaic panels on board construction equipment? I guess the power needed versus cost, kind of the trade-offs there. Do you have any thoughts on that?
Yes, in the end, I think photovoltaic panels are engineered to put it stationary and not on the mobile applications. We've seen probably some cars. I would say it's more marketing than anything else to put solar panels on mobile applications. But nevertheless, if I look right outside my window and I see so many buildings with flat roofs, nothing up there, just putting their solar panels, full day, you're having probably sunshine, depending on the weather, but always the availability to having it in the perfect angle to your sun direction, put the solar panels on stationary applications and not putting it into machines.
Right, very good. And maybe one last question here. So in your view, kind of where do you see the future of electrified construction equipment? How much penetration, how much market share compared to, I guess, the IC versions?
We are also waiting for the hockey curve, as in the electric vehicles or electromobility is happening right now, probably, definitely in some European markets, and also some foreign markets. But in the end, it's a hard question. I think the technology is here, and we're seeing the easiness to start on smaller applications as these 2-ton excavators with 40 volt, 48 volt systems. The penetration will be probably already on 2030 at 20%, 30%. With high voltage architectures, it will be a little bit behind. And I heard once a good statement in the end, who drives these markets at the moment, it's also driven by countries, by legal legislation to give benefits to use environmental friendly applications, because it's not money to put back in the pocket. It needs to be regulated somehow. That's definitely one key enabler. Therefore, I think the technology is ready. The scaling of the markets really helps that electric mobility is already implemented into vehicles and also trucks and buses to make the components more cheap for these applications. And then it's, I think, very dependent on the governments how to decide. And in some applications, which are just making enough money through fuel saving, through maintenance, there are definitely some of these which are using probably also stationary or semi-stationary, which the battery capacity can be very small. That penetration will be very quick then.
And I'm sorry, one more came in while we were discussing that. So can you comment a bit maybe on the performance differences between hydraulics and electric cylinders? And I think specifically this person is asking about in the tear-out tests for the bucket's penetration in the ground. Did you find any more difficulties with one method versus the other?
I think it's a good question, and we have seen that this first machine we have built, it is an OEM involved into all the tests, and they have it throughout the last couple of months in their test lab. And in the end, what we have seen as results is that, for example, the speed of movements, we can already bring it to a level, and also the control of the movements, that's probably a little bit more challenging. For example, bucket shaking, both directions, full torque both directions, and making that happen throughout the electric cylinders. There are specific topics definitely to challenge, but so far we have seen very good results and very good feedback of making all these potential features and requirements happened. I think the challenge is the lifetime. In the end, that need to be analyzed more in detail. Shock dampening and vibration in this harsh environment with dust, dirt, and others. That will be probably the most crucial topic to solve. But in the end, the other requirements, I think we are at the step which the most is already fulfilled or nearly fulfilled.
All right, thank you very much, Stefan. It's been quite an interesting discussion here. Thank you for your time in presenting, and thank you to the audience for joining. Please remember you can join your next session through the lobby, and that the recordings will be made available to you after the conclusion of the conference. Thank you very much.